Good morning. Oh, yeah. The show. It's time to start the show. Good morning. Welcome to Gruber Power Services Power Hour. My name is Claude Dixon.
And I'm Elvis Venter. And man, I am excited.
Yeah.
Happy. Maybe because it's a 3-day weekend
Here's
coming around.
Yeah, 3-day weekend, Christmas, turkeys, all that, family. But here's the thing.
Oh, no.
We're going to go down a rabbit hole like no other rabbit hole today, and we might need your help to get the hell out of it. Okay?
You said rabbit hole.
Yeah.
That's what I said to Pete.
I know.
When Pete came to me, he's like, what are you guys doing today? I said, we're going down the rabbit hole.
Yeah.
We are going down the black hole.
Yeah, this is going to be interesting.
Yeah.
But first, like we always do, we would like to just thank our subscribers.
Oh, man.
We had another 30 from last week. We were at 1,332.
31st cousins.
Yeah, today we're at 1,367. And Richard, if you could put up image number 12, I want to show you all these folks.
Ooh.
Look at this. This was the gap from 1332 to 1367. These guys right here.
A lot of felines.
Okay. Yeah. Look at our new subscribers.
Wow.
You guys realize, you guys know this, right? That our subscriber base is basically family members, cousins, cats, and there might be some dogs next week. We don't know. But
Which one is yours that
one?
you relate to? Mine's blue.
Well, the one right in the middle, obviously.
Okay. Hey, you have a gold chain like that too.
Exactly.
I've seen that gold chain.
A big one. No, these are Egyptian cats.
Oh, wow.
Some of the souvenirs.
Just like you.
Yeah, some of the souvenirs that I picked up in my trip to Egypt, they're really unique and interesting
they're
to look at.
beautiful.
Yeah, I really like
You
them.
brought them in the office, right? Not
No,
yet?
I haven't brought them in yet.
Because they're
Haven't brought 'em
watching.
in. Yeah, they're watching us, and
Man, but look at, they're watching some studs right now.
yeah, and they have a lot of babies quick, just so everybody knows.
Exactly.
Okay?
But you know what? Can I say something? You said,
Sure.
oh, it's friends, it's family, it's cousins. You know what, though? As cliche as it might sound, I'm going to say it because I'm still about a year and a half in, and I really, really believe this, and I feel this. Gruber is a family. The stuff that we've been doing here, the people coming together. I mean, look what Nicole and Jennifer, look what they just made us. These hot chocolate cocos.
Who's
My
Nicole?
8-year-old.
Who's Nicole and Jennifer?
Nicole Bowser.
Yeah.
And Jennifer Chapman.
And Jennifer Chapman.
And they're part of the Gruber family team. They work a lot. They're hard workers. My 8-year-old would be so jealous right now to see that I'm just sipping on hot cocoa. And they made us for the whole crew today, a hot cocoa bar with snacks.
Exactly.
I mean, just a family approach to feel it is a family. So if you're a cousin or you're a bunch of cats or dogs yesterday morning, I didn't tell you I came in at 6 and I went for a walk. You know what I saw? A raccoon.
Wow.
And I looked at him, I said, hey, are you subscribed? Because I was like, you need to jump on the Gruber family. Everyone's family.
Yeah.
I don't care. As long as people are here and they're enjoying it and they're part of this team, that's what makes this platform. And we've grown to over 1,000.
And even the tech guys.
Come on.
And even the tech guys.
Big people.
We've got tech guys on here too.
That are amazing.
And we love the tech guys. And we're going to introduce one right now that's going to help us. That's going to help us get out of the rabbit hole that we're going to go down.
Okay, so you brought some help.
Yes.
I appreciate that.
And his name is Lenny Hodges. Lenny is our senior module repair technician. And our topic today is PCB, which stands for printed circuit boards. Come on in, Lenny. Come on in, take your seat, check your mic out, drink some cocoa.
Oh, yeah.
I know some of you guys will remember Lenny. He's been on I think he's been on 2 past shows.
Yep.
Yeah.
He came in and held down the fort when you were gone.
Yeah. Yeah.
He came in clutch.
Yeah, he subbed for me one of the weeks I was gone. Merry Christmas.
Merry Christmas.
And thank you for coming and helping us out again.
Not a problem.
Again. So, like I said, the topic today is PCB, which stands for
Printed circuit board.
Printed Circuit Board. And I hope that we don't bore you with the number of images that we're going to show you. So here's how we're going to do this. We're going to show you a UPS with the door open, 2 different types, a modular and a component UPS with the doors open, so you can see what we're talking about and see the differences between those 2 types of UPSs. And then we're going to walk down through the common boards that are inside of a UPS. We have some pictures that we're going to show you. And then Lenny is going to dissect one of these boards for us. We're going to talk specifics like the microprocessor, what does it do, that type of thing. And then at the end, we're going to basically talk a little bit about what we do in our depot in terms of modular repair.
Yep.
Okay, so that's an action-packed podcast. There's a lot there. This guy is really sound, very technical, and I love working with this guy.
He's our go-to.
Yeah.
I mean, I go to him all the time, and I ask him, and I talk to him, and he's giving me information in general. He's giving me updated info. He said, hey, this is the new policy. This is the new change. This is actually the reality. So, yeah, I appreciate it.
Yeah, yeah. All right. So, Richard, can you put in image one? Image one. Okay, so what you're looking at here, we're going to show you two different types of UPSs.
Really
okay?
quick, gentlemen. So I recognize that Lenny is cut off here in the middle. I'm going to work on fixing that.
Okay.
Well, we got 4 guests now.
Yeah. Okay, so that you're looking at what we call a component UPS. And remember, last week, we showed you if that door was closed, we showed you the display that was on the outside of the UPS, and we talked about the functionality and the capability of the UPS display. So this piece that I'm holding in my hand, the part that you can see, is on the outside of the UPS when the door is closed. So now we have the door open, and you can see what is inside of this component UPS, and you see a lot of PCB boards. In fact, there's a PCB board on the back of the display that runs it. Okay, so we're going to be talking about those boards that you see in there. Richard, if you could put in image 2. You'll see the difference between the two types of UPSs in terms of technology. This is what we call a modular UPS. You can see there's a significant difference between the two. You see the power module, well, you see the, what's that up at the top, Elvis? The two, those are the two intelligence modules up at the top.
The MIMs.
Yeah, the
MIM 4s for, this is a PX 80 kVA from what I could tell. And Lenny, you can confirm that because 80 kVA comes with the extended battery cabinet to the side, and it looks like they populated batteries in an 80K, or
No,
it
that's
might be a 40.
This is a
40 with an extended battery cabinet.
Yeah, Lenny, just walk us through it real quick. What we're looking
this is a 40K unit with an extended battery cabinet. Yes,
there it is. Okay.
So your top 2 items are your main intelligent module, and then off to the left side is your redundant. They're both the same. One's just main, one's redundant in case it goes down. Then you have a blank space for if you want to put another redundant
power module
in there. And then 4 power modules, and of course the batteries. Now the batteries have to be in a row of 4.
Yeah.
So
which we call a string.
Or a string. And then down at the bottom you have your static switch, you have your display, your network card, your gear card, switch gear card, and stuff like that.
Okay. So the other thing too is you see some black spaces. What are those about?
Those are blank spaces for if you want to put, like on the left side, the top blank space is for an additional power module. What we do is we call that a redundant. It'd be a 40K, 4 units with a redundant. In case one goes down, that redundant one would kick in to help out. On the right side with the battery cabinet, those are blank spaces for extra batteries.
Gotcha.
So remember, we've talked about, and look at what you see how deceiving that is? I thought it was an 80K, and then once I saw the batteries on the left, it's like, oh no, actually it's a 40 with an extended. And the whole point of the extra cabinet is for more runtime.
Right.
We've talked about that many times, is to get more runtime. They want to get 20, 30, 40 minutes added to what the UPS is already doing.
Right. And to your point, Elvis, and, just to define, you hear Elvis use the terminology extended. Sometimes that confuses people, especially if they're new to the industry. Extended, basically what extended means, it's an extra, an additional battery cabinet that you see there to the right. So what I want to do, pretend right now like you are at your optometrist, and they put you in that machine and you go, this one or that one, left or right. So, Richard, if you could go back to image 1 real quick. Just want to, see what that looks like? Just paste that in your mind, how that looks, and then go back to image 2. There you go.
I like this one.
All right. So, when you talk technology, this is kind of like, can I say the new stuff? The modular stuff?
More
Can
updated.
I say that? Yeah, the more updated type stuff. This is what the industry has slowly transitioned to over the years from what I just showed you, because the UPS I just showed you is 10 plus years old. The first picture I showed you, the component UPS, and now here we are with this. And we've watched our business here internally, even in the depot modular repair area, we've watched our business internally just slowly transition over the years to the modular output, which is really cool. Okay, so there you go. Paste that in your mind. So the question now is, what kinds of boards are inside of a UPS? So Richard, if you could go back to image 1 real quick. Okay, see that there? Go to image 3. So the first board we're going to show you is what they call an input rectifier board. And the purpose of what I'm going to do now is just show you each board, the common boards. There's more than this that we're going to show you, but these are the common ones. If you go from UPS to UPS to UPS, these are the most common ones that are inside. We're going to show you. So you're looking at an input rectifier board. Some of the things that you can see as we go through them is the difference in the size. You know, they're different. The heat sinks are set up different. That's some of the stuff that Lenny's going to get into later. So that's image number 1. If you could put in image number 3, I'm sorry, image number 4. This is what we call a battery charger board. I think you can see pretty quick that that does have something to do with a battery, because what do you notice on the top there?
The fan.
Yeah. See that little fan on that's lodged, that's mounted on the circuit board? So this is what they call a battery charger board. Image number 5. Okay, there you go. You're looking at an inverter board right there. That's what they call an inverter board. Oh, by the way, the green plastic, we want to get some guesses from our audience on what you think that is made of. Just go ahead, look at that, the green that all the components are mounted on. Please don't Google it, because it'll pop right up if you Google it, but just use your thinking cap. They used to say that in the olden days. And
We brought ours.
yeah, and give us some answers on what you think that is. Okay, we got a lot of stuff coming through here. Elvis.
Uh-oh. Okay, let's hit some of the comments. So Loretta Bauman, hello everyone, IT manager. You guys look warm. How we feel warm? We look warm. I love the hats. I mean, Claude, what are these made of?
These are made out of alpaca from Prescott, Arizona, the alpaca farm up there.
Very cool. Jesse JB, looking good, guys. Love the hats. Larson, looking warm and good morning. Good morning, Larson. Oh, there he is. Grant Mobile. Love the headgear, fellas. YouTube Highlander. Great to see you, Highlander. Merry Christmas, gang, and kindness is always free. Highlander. Hi, Lenny. You know Highlander's like your number one fan. You know that, right?
At least I have one.
It's the FEs, and they just stick together. Highlander, go Air Force. Loretta Bauman, Elvis has done his homework. Thank you, Loretta. Master King, MIMS, correct. Per that, it was the MIMS, the intelligence modules. Ernesto Garcia, great to have you, Ernesto. You are doing, I think, a clap or a hi. Good to see you. Highlander, the panel is not compliant to finger touch. Oh, okay. Dream Traveler 008. Hi, brothers. Hello, brother. Hairstyle. Thank you, Dream Traveler. Yeah, it's our hair. It looks like it's part of our hair, the hats. Gruber Service. Welcome aboard, Lenny. Instagram, DMN.K. Where's the UPS that you guys are talking about? How can we see the images? So per Instagram, what we would advise you is jump on YouTube for the time being. And if you jump to YouTube and you go to Gruber Power Services, you're going to see the images we're talking about, DMN.K. Chemistry.
Real quick, we may have the ability to show the green screen images shortly on Instagram. However, as of right now, the best place is to go to YouTube.
But not
Same
today.
Thing. Well, go to YouTube today, but we don't have the images today for Instagram.
But for Instagram, not today.
But they are coming soon.
Chemistry, love the fuzzy Antarctica hats with the short sleeves. Yeah, I know, right? Redundant, or not even. Chemistry, are those wigs? Nope, not really. Invert. I don't think I need a wig. Claude, well, you're good. It's up to you.
Yeah,
it's per choice.
I do.
But you went with the blonde. Are you a blonde?
Yeah. Yeah.
Loretta Bauman, inverter board, correct. IT manager, industrial UPS, chemistry, sugar and food coloring. Yep, that's what we were taking care of here. Loretta Bauman says breaker interface board. Yep.
Okay, I think we had two responses that were referring to what that PCB is made out of, the green portion of it, and it's made out of fiberglass, just so you know. It's a fiberglass board that these components are being mounted to.
Skis and snowboards are made out of fiberglass as well.
Lenny, real quick, just on that, and this, I may be probably didn't get you this question, but the fiber, I didn't Google it either. The fiberglass, I mean, why the fiberglass? Do you know?
It's flexible. It can withstand, like, because you'll have boards like this who get hot, they're mounted or something, they can warp, but they're easy enough to drill through to replace components, to replace tracks, eyelets, things like that. But it's also to the point that they can be more flexible
Okay.
within a unit, because sometimes you got to kind of flex a card to get it into. Also, you have to have a material that can get hot. And withstand the heat, absorb the heat, and fiberglass does that. I mean, you do it with your car.
Yeah.
You do it with a lot of other, things out there. So it's got to be flexible enough to withstand the heat, but it's also going to be flexible enough to get it in and out of the unit without cracking or breaking real easy.
Okay, I hear you. Okay. All right, Richard, go to image number 9. Image number 9. And we're carrying on with the common boards inside of a UPS here. So image number 9, when it comes up, is what they call an output voltage regulation board. Output voltage regulation board. Number 9. All right, we got another comment up here from YouTube, breaker interface board. Another comment from Kim. The green thing is food coloring and sugar. The green thing.
The board.
Oh, yeah. Yeah. So there you go, an output voltage regulation board right there. Richard, image number 10, if you will. All right, communication right here. This is a card. Communication, you slide this into the UPS. Communication interface board is what that is called technically. Image number 7.
cards.
Yeah.
Is also right.
Network card.
Network card. Card.
Yeah. Image number 7. And I talked about that at the beginning of the show. It's going to pop up. It's going to be a board right here. That's that right there.
That's behind the display.
Yeah, that's behind the display. It's attached to the display portion of the board. They call it a display board right there. And you can see the ribbon cables that connect inside the UPS. Okay, what else do I have here? Image number 11. Image number 11. Okay, you can see that board there. That's a bypass switch board.
Assembly.
Yeah.
That's a heavy piece.
Yeah, you can look underneath there and see. And these images I actually took off of the internet. So it wasn't anything that I handled in my hand. We do have some of those up front here. You can see. We're going to talk about those a little later.
I know where you got that image exactly.
Where?
I took that picture.
You did?
Yep.
With your iPhone?
Yep. Years ago.
Okay.
You found it on Google, and
That's
I know
right.
where you got it.
Yeah,
I know.
you're the parts guy. That's right, with the other company. I keep forgetting that.
I know
Yeah.
exactly, because I used to have that backdrop, and I took care of that exact picture, and you didn't even know it.
No, I didn't.
No.
That's a photograph that Elvis took when he was with another company that's on in the internet. You can just go to images, and there it is. Boom. I didn't know that. That's cool, though. And then image number 6. This will be the last image we show you of the different common boards. Image number 6 is a fan control board. Pop that up there. There you go. I think we showed that, but that's okay. So image number 6. All right. Do you guys know who the man was that got the first patent and what year it was on a PCB? Any ideas, any guesses?
1874.
I mean,
In the
wow,
1900s.
1930.
That's pretty close. So 1943, a guy by the name of Paul Eisner, he's actually from Australia, was the individual, the man, the person that got the
Not
first
bad.
patent on a PCB. And it's been forever developed since then. So I thought that was pretty cool. All right, so now we're going to put in some images that Lenny gave us, and we're going to dial down now. Image number 13. Okay, so we're going to start with the microprocessor, which I'm going to have Lenny point out where that is and then talk about what its function is.
Okay, so this is a control card. Basically, it's the brains and operations of a 4KP that goes into an LX UPS. Dead center, that square with the label on it, is your microprocessor for this. So it's like a microprocessor inside of a PC. This controls every function, tells what the unit to do, helps communicate with the unit and everything, because your data cable is the top left side over there. and then but the microprocessor is dead center. So on this board also,
Hold on one second on
I'm
the
sorry.
microprocessor. So when you say the microprocessor communicates with the rest,
yeah,
because there's other
basically
boards inside.
there's other boards inside of the unit that this is talking with. I mean, like I said, you take a computer, you have your microprocessor that's processing everything that's coming in and out, you know, and that's what this is doing, along with communicating that to what it's supposed to be doing and monitoring everything in the boards
Okay.
and inside of the unit. So it monitors it, it processes it just like you do with a computer, and telling it what to do. If you know, this will actually alert the processor itself won't alert faults, but it's monitoring and then, you know, telling it through the display, like you had on the component side. You have a display on the modular side, and it's running everything through the unit, telling everything what to do, and then that display is coming from the MEMS, which we talked about, and then that the communication, what it's supposed to be doing from the power module to the MEM, because the MEM has its own processor also, and then from there it's communicating to the display so you can see what the faults are, what the what your voltages are, what your frequencies are.
And when you say MEM, you're saying that you're talking the main intelligence
module, which
and
has its own processor.
Yeah,
as
and there's
unit
also a redundant one too.
Right,
correct?
and the redundant in case the main goes down. But inside that MEM, it has, like I said, it has its own processor for the functions it's doing.
Okay.
Also, and they all communicate with each other. They all are doing a certain thing within that UPS.
Okay, so before we go on, so if you go, we're not going to show the image, but the very first image we did show of the UPS with the door open and you saw all the circuit boards. Okay, this processor, this microprocessor that Lenny is talking about, sends signals to all those other boards. Correct me if I'm wrong, Lenny. Sends signals to all the other boards to get them to function. It's like the brain.
It's the brain for that card, and that control card controls the power module. Then inside the MEM, it has its own processor on a control card. That control card controls the MEMS, but they all have certain processes that's functioning within inside that unit. And those units talk to each other based on the software and their firmware and how they're supposed to interact with each other. But yeah, but each individual item, even including a power module, has its own. Within the power module, you have the control card, which has its processor. So it's doing its basic functions, and then the MEM has its processor, which is doing its basic functions, and then they're able to talk to each other through data cables, through communication cables, and then based on the firmware and the software written for the unit, that says, are you meeting certain criteria? Are you doing this? It's telling it what to do, but it's flowing in and out of that processor.
Gotcha.
So yeah.
Okay. We're going to go on and keep talking about this. So now another component on a board, it might not be this one, we have two other images, is the power inverter, which converts DC power from battery to AC and onto the devices. What is your perspective on that piece of it?
As far as
Yeah, the conversion process.
it's basically because basically dealing with a higher voltage, inverting it, you know, like it's like almost using it as a transformer, basically in this case to charge the batteries to, you know, from AC to DC. We don't deal much of it with the modular side. I mean, we do with the modular side to the point, but that's all based on there's another card once we show another image with a power factor control card, which will controls all the power in and out, tells it, okay, this is a battery charge, you're supposed to be charging the batteries based on this, telling it what to do.
Yeah, let's find that. I think it's image number 14.
Excuse me.
Richard, if you could put that up real quick. It might be image 15 too, because you gave me 3. Is it on this board?
This is a power supply card.
Okay, so it's on 15.
Even this little card actually is the power source for like the PX that we showed before, the power module.
Right.
This card actually functions to power the power module.
Okay, and what are we looking at here? And again, I'm asking questions because I want the audience to ask questions too. When we look at this board, this piece of green fiberglass, and you see all these different components, what are we looking at here, and what's the function?
If you look at the two, the large circular items, those are capacitors. Those basically filter and steady electricity that flows in and out.
Yeah.
Excuse me. Then you have your resistors, which have a frequency as far as allowing certain voltages in and out.
And the resistors are the ones that are lying flat.
The resistors are the color banded ones that you'll see. You'll also see them. They'll look like just a piece of square metal because of what they do.
Richard, can you magnify that anymore?
Yeah,
okay.
That's a resistor right there. The color bands, it tells what frequency, it tells, okay, this is how much voltage is supposed to be going in and out, flowing through it. If too much voltage goes in, it'll blow. That's a safety reason. So if you move over to the left-hand side where the black and silver are right there, where it says D801 and D800, that's actually a diode. Diode flows electricity, but it flows in one way. And a little tidbit for you guys, the first diode developed was in 1874.
1874.
1874, they were actually able to develop the first diode, which actually, to give you a little history lesson, a CRT, a cathode ray tube, is a diode in your old TVs. Electricity flows in one way. So, and it acts like a resistor. It acts like a fuse also. If the somehow power backfeeds, it'll blow for safety reasons also.
What year did you say?
1874. They
You
found
were way off. It was 1873.
They found the first materials to actually do the
You were so
diode.
close. Yeah, you got it. But it's 1873. Way off, brother. Come on. I'm just kidding. But it is 1873. No, you're right. It's in that.
Guthrie was actually what they call the father of modern radio, father of the television.
Okay.
Because of that discovery.
Was that your great great grandfather?
Nah.
Yeah.
Mine was a moonshine.
Yeah, you were really close. Yeah, 1873, 1874.
So how about the maroon components that are standing?
Check you.
Some of those could be capacitors. I mean, capacitors always look different. There's surface mount, there's through hole, there's radial, axial, whatever. They comes in all shapes and forms. So it could be a capacitor, it could be a diode, a thermistor, a variable resistor. There's a lot of things that come in. Like I said, if you look underneath the large circular one there in the middle, if you go down to the bottom left of that, the middle where it says C8, that's a capacitor.
Okay.
Yeah, that's faint, but you could see it. The one that's more like bronze.
Yeah, the one that's,
Okay, right there, yeah.
Yeah. And then if you notice next to that, it says R. That's a resistor. Like I said, resistors can come in different ways too.
That's deceiving because they both look like caps.
They look the same.
Yeah. They look like a battery too.
And of course, you got the yellow winding right there. That's a transformer. And the function of the transformer?
Oh, that's stepping down your voltage.
Okay. And if you could go back up, just scroll back up.
What's the name of that transformer? Optimus Prime. Aaron was about to say it. Aaron was leaning in, and I took it
We
from
talked
him.
about it last week, didn't we?
Huh?
We talked about it last week,
Yeah.
didn't we?
Not Optimus, the transformer.
Yeah, we talked about it last week. It
Yeah,
starts
we
with
did.
an F.
Yes.
Yeah, I can't pronounce it though. It starts with an F.
Oh, the name. Yeah.
Okay, so what about the black pieces there? This board right here, look at this. It looks like a little city.
This is a circuit chip.
Yeah, you look at this.
You talk
Looks
about
like Tron.
Yeah,
Oh, okay, so that is actually a heat sink
yeah.
that ties to an IGBT or a MOSFET, which is basically a semiconductor.
Yeah, so point that out, Richard, if you can point out the heat. Yeah, right
So
there.
the heat sinks are right there because IGBTs, MOSFETs, they actually get really hot. So you usually have a thermal sleeve between that or thermal paste like you do on a microprocessor or a microprocessor fan inside a computer. But they get so hot, you have to have a heat sink to dissipate it from the board. I mean, you still get discoloration too in the fiberglass if it gets too hot, but that's the functionality of it. And most of them are made vertically. I mean, if they were to lay these things horizontally across the board and you have more of them, and the board could be 2 to 3 times larger. So going vertically not only makes the board smaller, but think about it, heat rises. Dissipate the heat's coming up off of the board by making it vertical also.
I see. Okay. Yeah, if you could zoom out. All right, and I see something up, those are heat sinks up at the top right too.
Yep.
I see another transformer.
What are the blue?
The blues, which blue?
Those 3 little blue.
Those
are those diodes?
Those could be variable resistors.
Okay.
Yeah, and then the blue square is most likely a relay.
Okay.
Okay, so if I was to go give this circuit board to somebody in sales right now, and ask them to point out these components, read them to me, tell me what they are, what's the language that's included on a circuit board?
Well, if you look at it, everything is kind of marked as an item. You have your R for resistor, C is for capacitor, HS is for a heat sink, a variable resistor will say VR, a thermistor will say TH, IGBT, MOSFET, those will be labeled too.
And that's what the white lettering is we see from afar here.
Yes, that's what the white lettering is. And then, of course, IC is for your circuit chips that are in there. So like an IC right there can get hot. If you want to keep, heat away from an IC or protect it like that, you put a thermal casing around it.
And the significance of the number, like R858 is
all
just...
that is just a label.
Okay.
It's just a label. It's like labeling a power cable L1, L2, L3, neutral, ground,
Yeah.
So it's just a label that they use. It has no significant meaning unless you're looking at a schematic and doing point-to-point troubleshooting.
Okay. Got ya. All right.
Some of our
Go ahead.
comments. Master King says fiberglass, non-conductive material. Brandon Mahim says, hey, Uncle Lenny. Nice hats, Brandon says. Highlander says ATT. I don't know what that means. Help me with it. Highlander, wow, you guys are really getting into it. We are. Today's a rabbit hole. Claude did say that. Highlander, do these cards use token passing, or is this application just too small? And Ernesto Garcia, do these boards ever come with flux capacitors? So those last two, maybe if you want to answer those, Lenny. But a quick pause. We have another great guest coming through, just a visitor. Want to say hi to Loretta. Look at Loretta is here. And the Shades. She's a really great... Hey, why don't you jump in? Say hi really quick.
Hi,
Look,
guys.
she's always on the show, her and her daughter and the family affair. Everyone's coming to say hi. So we want to say hi to Loretta.
Yeah.
She just crashed the show.
Yeah,
Yeah,
Loretta
I
is one of our key employees here. Loretta, what do you do here? I've known you for 5 years. I don't know what you do. What do you do?
She picks on me.
Yeah.
Here.
I do RMAs, which is return material authorization. I do battery pickups, and I do tech calls.
And she picks on Claude and me.
Yeah.
Always.
And this was,
The
the
bully.
last show, this was the person on the last show that typed in when we asked the question, did you know what was the most expensive car ever?
Yeah.
Ever.
She said Toyota.
He said Toyota, man.
I figured I'd get a laugh out of it.
Yeah. That's going down the Gruber Hall of Fame.
That is so hilarious.
That was Toyota, yeah. I
Anyway.
still didn't find it.
I'm out of here, guys.
Thank you
right.
for jumping in. Thanks. Look at that. That was fun. Look at that. Any more people just hopping on in.
All right.
It's
So,
a-
Lenny, can you hit these questions real quick?
Yeah, the last two.
The token passing, the application is too small for that. Flux capacitors, that's actually a comment. That's actually a thing from Back to the Future. If you guys know that the DeLorean had a flux capacitor. Flux is an item that we use to help solder flow, or when you're soldering chips, and then a capacitor obviously is a part.
Yeah.
So.
I like this next question from the Scheffler family. Is the board we are looking at something that we should replace or repair in a UPS unit?
Ooh, that's a good question.
That's a great question. I have my answer.
Both.
Okay.
We replace it. If I have a unit and it's dead in the water when it comes in.
Okay. Well, first of all, I'm sorry for interrupting you, but the board we're looking at
There's a power supply card for a 10K.
for a 10K kVA power module that goes inside of a
PX.
APC PX.
That's
okay.
5 p.m. 10KF power module.
All right. So this board is coming out of a power module. Go for it, Lenny. Sorry.
So this is our power supply card. The power plugs in from the main boards, plugs in from the connector to this, and then the data cable plugs into the control board. And the control board functions from there. But without this board, that module doesn't even power on at all. So if it's bad, we have a set that we'll do an instant replace to get the module up and running. And then I'll go back, point-to-point troubleshooting, replace any components that need to get it fixed, and out the door. Now, sometimes, like you guys, go down a rabbit hole, there's going to be parts we cannot replace.
Right.
They no longer make the part, or there's not a compatible part, or we don't have the proper schematics for some of this sometimes, because like an integrated chip, you don't know how it's going to flow. If you don't have a schematic, you don't know how it's flowing signal-wise in and out. Unless you take a good board with a bad board, and then take a waveguide and go through everything, rotoscope or whatever you have.
Go ahead, Claude, because I got a big challenge.
Yeah.
I'm about to throw a wrench in this whole situation.
Okay. Well, here's another thing, Lenny. I mean, you hit a lot of really good points, and I just wanted to just tell our audience that, he's talking about basically dissecting the board. So there are times when we have customers that just send in their power modules, and they send them into our module repair area. We open them up and we troubleshoot them and we repair them and then send them back. That's part of what we do out there. We do provide that service. So if you have a machine that's been running for 5-6 years, power modules have not been looked at, it might be something you want to look into. We provide that service.
Yeah, we do.
Yeah.
Now, here's my thing, and I'm going to add to this, and me and you, I want to hear what you have to say on this. And this is how I look at it. I believe with boards, with PCB boards, it's twofer. It's two parts to it. It's like this. When we're talking about boards and parts in a power module, in a battery module, that little chip, in power modules, in battery modules, in a MIM, an intelligence module, maybe even a static switch. I think repairs are more common, more feasible, more realistic, and we do that and should be done. But I think now, because majority of the stuff those are for modular units we're talking about. We're talking about boards, PCB boards in a modular unit. We have not talked about for a Liebert AP600. We haven't talked about for an Eaton 9390. So I think when it comes to things like that of a modular, even for the Eaton 9170, a power module, the 0673 can be repaired, and the boards and the caps and so forth. So that's a highly likable situation of a repair.
Yes. Well, now. Can I throw the wrench back?
Yeah,
at
because
you?
I'm not done yet.
Can I throw the wrench back at you now? Mine's bigger. No, I'm just kidding. Just kidding. No. Valid point. But here's the other thing. Why the discussion is so much on modular units. It's because they're redundant.
Yes.
The components are redundant. So you can take this part out, and that unit's still going to function.
Correct.
The 9390, the 93.
You're done,
yeah. You take that board out. Guess what?
And that's why I think it's a twofer.
No,
You're done.
You're done.
Yeah, that's why I think it's
down.
a twofer. That's why I really think it's a twofer. For modular, for power modules, for battery modules, repairs is the first priority in my opinion. Or if we got to, if it's unrepairable power module, I get it. Replace the power module. But the power modules, the battery modules are repairable from the boards, from all that you do. I see you work on the diodes. I see you work very, very skillfully and very detailed. Now, when it comes to answer her question, which is a bigger question she may have realized or not, when it comes to a Liebert AP600 or a 610 or a 9390, 160 kVA UPS,
we're going to find it. We're going to find the part.
Finding the board and replacing it from our stock is our first approach. Then sending that board back, which they won't because then it brings down the unit.
Time sensitive.
Exactly. Or finding one here and repairing it. No, we have the ones available that have been come out of a tested unit or have been tested, and we just replace. Yeah. So for certain UPSs, we go straight to replacement on PCB boards.
Good point.
If it's the inverter, if it's the driver, if it's the board for a display, if it's a small... The power supply boards are a dime a dozen. We have so many power supply, little assemblies, power supply for the Eatons I'm talking about, with the little... Those are, and with the heat sinks, we have so many of them that he doesn't have to go through and try to repair them because they're available and ready to swap out. So I think it's a two-part. I think depending what it is, repair is priority, and depending what it is replacement's priority.
Yeah.
Yep.
No, that's a great point.
Well,
great point.
Same thing. Well, even on a PX or an LX.
Yeah.
A display, a communications card, a network card on the backside, a switchgear card on the PX.
Swap them.
Swap it, get sent back. fix it.
You're not going to work on a
You know
Thor's
what?
hammer.
You know
You're
what?
not going to work on a Thor. Check this out. You're not
Thor's
going
hammer, but I've never, in 2.5 years of doing this, I've never had a Thor's hammer go bad.
Exactly.
They don't go bad.
Hey, you
There's
know
certain
what?
components that never
And
go
Thor's
bad.
hammer has a family. You think your cats have hundreds of families? Thor's hammer is one of the most common name on that APC board, and there's different types of sizes per the back of the UPS for an APC and an LX.
You know what?
And
I
maybe an
said this in
APC
another
PX.
podcast in a galaxy far, far away.
You know I
'Cause
love
this is number
PCB
28.
boards, man.
No, but check it out. It's, you know what it really boils down to when it comes to all this stuff we're talking repair, replace? It comes down to uptime.
Yep.
Okay? That's what it's about with the customer. Okay, 100% uptime is what they're looking for. So anything that you can do to shorten that critical
Exactly.
path, yeah, it might cost you a little money, but what's the objective? The objective is to keep that customer up and running.
I had a customer brought one in and said, "Hey, I'm good. I don't need anything right now." They brought an entire LX and they said they wanted us to repair the entire LX. So we put parts in the back. We put a Thor's. We did all this, and it was no problem. The input board, all that stuff. So, like you said, time sensitive and uptime per the customer.
Yeah.
One just said, "Hey, I need a new UPS. I need a new power module. I need a new backplane. I need something ASAP." So that all depends too. But for the component UPSs, it's usually replace it with an updated board, if it's the Rev, if it's one we have in stock, if it's from the OEM, because like for Eaton, they carry new and used in their stock, depending the UPS and depending their stock.
And that doesn't even matter either, you know, to your point. It doesn't even matter if they have a backup unit. You could have another UPS that the load switches to while that component UPS is down.
Agreed.
The sense of urgency is
Is
just
important.
as high.
It's very
just
high
as
priority. So
Yeah.
that's why when someone says that's probably one of the best questions I've seen. And for today, fantastic question, Ms. Scheffler. Family, amazing, because it is true. It depends what for a display like that, Claude, that you're looking at right there. That one that you have on your table.
Yeah, which one? Because I got two.
The other one. If we have 10 of those. If we have 10 of these PowerWare 9355s, 9335, oh man, this is an oldie.
Yeah, it is.
And remember what I said a few episodes ago? Depending on the color, you can tell if it's older or not.
Yeah.
And this is that tan, which they had like in production.
Mm-hmm.
If I have 15 of these, I'm not going to send this to have my customers send me their old one or have Lenny repair it. No, I got 15. We'll send you a replacement. Enjoy it. It's operational. We checked it. We plugged it in. It's working. I'm not going to go have Lenny, hey, can you go play with this card? And no.
No, that's when we get it back. And it comes to the point, even on component, I mean, in Swaptronics, you're swapping out, like you said, uptime. We had that in the military too. It didn't matter. We have depot repair facilities for certain equipment, and then we have what they call online facilities. You know, right? The online facility maintainers, they go out, they replace what needs to be right there. Then you send it to the back shops, you send it to the depot for repair, because you got to get either a weapon system that's gone down, you got to get that back online, you got to get computers back online, you got to get aircraft off the tarmac.
Okay.
So basically, you got the online stuff like our field engineers are doing. They're the online maintainers. They're doing it in the front lines. They're replacing what needs to be done to get the customer up, and then they send it back here, back to the depot, back to the back shops. We're fixing up to replace that stock inventory so they can go back on the front lines or, you know, do the online maintenance and get them back up. I mean, we did it in the military like that too. It's just the same. It's just different terminology.
Exactly.
Same concept though.
Well, Lenny, I got something ugly I got to show you. But I got to get up and get it.
But it goes back to even what you've said, Claude.
Keep going.
About being that approach of, oh, I've had customers, I just want to repair this. Okay, we'll repair it. And then I tell them, hey, but we don't guarantee repair. We don't guarantee it's repairable. We tell them if repairable, we'll repair it.
Yeah.
And a lot of times they just want to skip and say, hey, man, can you repair these too? It's like, why don't you just get a refurbished one that Lenny looked at, he touched it, he brought the microscope in, he maybe put brand new caps and fans in it, you have coverage and warranty on it, and just go for it. Sometimes it's like they want to go with that cheaper option, but they don't realize it's like, hey, you're sending us something that we don't know about, wherever it's been. And to this point, it's a segue to this. I recommend a customer replaces because you touched it, you've cleaned it out, you've put your heart and soul of that specific, let's say 4KP power module. You've done all that you've done, and Lenny's the one that signed off on it. When we get something like this, Lord have mercy, from a customer, and they say, can you repair this? It's like, man, poor thing. It looks like it was neglected. Where'd you have it? In the mines? Probably, because it looks like that. So
Yeah.
a lot of times we say, I recommend, hey, we have replacements. Go with the one we have, because Lenny has put his care into it. He's looked at it. He's done everything needed. He'll do the same thing when we get this repair back, but it might not be repairable to where Lenny has repaired one that is repairable and done.
Okay. Yeah. Hey, just to be honest,
at this
just to
thing.
be honest with the audience, we didn't get through all the boards because of time, but I didn't want to miss this because this is a service that we actually provide out there. This is kind of like what Lenny is dealing with when he's out there doing his job. What you're looking at here is a power module that's been opened up, and I'm going to have Lenny walk you through. You can see this thing is really, really dirty and dusty, and this is typical. Keep this in mind. We showed you a modular unit. This is enclosed. This is put inside of a cabinet, of a frame, slid in, and you would think, golly, how did this thing get so dirty like this? But we encounter it. And
Yeah.
we go through our process of cleaning it, blowing it out, looking for things on the board that need to be replaced, testing it, the whole 9 yards. What, Lenny, in this scenario, do you typically find that's faulty?
And something like this,
Yeah, something like this right here.
God's honest truth,
Fan.
not a lot.
Really?
Fan.
Fan, maybe. If it looks like this, it's been working. If it comes in sometimes half clean, I mean,
But what would be the first thing that you would look at that you
first
think
thing I
goes
look
bad?
at is I blow it out, see if there's any blown components or anything like that.
Loose?
Then we take the fan completely out. We test the fan separately, actually,
Okay.
because are the bearings out or the winding is gone? Is it broken? Is a blade missing? You know, whatever. So, and then
This thing looks like it hiked through the Grand Canyon.
after we blow it out, we look for any components that common components that have blown or missing, have been broken off or something, you know.
Yeah.
Something that's, you know, you can see, okay, that's broken.
What's
Or
the
that's
first thing that
burned.
goes out usually? You've answered this before in previous episodes.
On this one, it's usually the fan,
Yep.
and there's certain caps that are on this. But you want to see a unit like this. And I'm not saying the customer having units like this. You don't want a customer having units like this. But seeing a unit like this means it's been working. It's been doing its job. It hasn't had to be touched.
But is it
You
in
know
a
what I mean?
is
But
it
it's
in a not
but
ideal
it's
location?
It's not in an ideal
Okay.
location.
Thank you.
Or it might be. It just was never touched. It could be there 3 or 4 years, never touched, but it's been doing its job. And when it's dirty like this, I have more confidence in a components looking like this because I know it's been working. I know it hasn't been touched.
Yeah.
But at the same time, on the flip side of that, you got to keep it clean like your car. You got to keep
The
engine
evidence
clean.
looks
You've got-
like-
you know, you've got to maintain it. And, you know, if that means sending the unit in to get us to actually properly clean it, to replace the fan if we necessary, you know, just to do a deep cleaning
Well,
on
check
it, to
this
do a
out.
detailing on it.
I respect your
You know?
I respect your knowledge, your technical
Right.
knowledge. But check this out. Check this scenario out. Okay, so I'm a field engineer, and I go into a site, and
That's how you would go at the site?
exactly. I would wear this right here.
I'd accept it.
Okay, and I pull out a couple of these modules, and yeah, I can't open them up, but I can clearly see that there's a lot of lint and dust right
Right.
there. Right, I can clearly see that it's in a dirty environment. You know what? On the ICPM, guess what I'm going to do?
You're gonna note it.
I'm going to reject it. I'm going to not pass the pre-contract inspection
Right.
because it's obvious, maybe it isn't, but it's obvious to me that this UPS has not been in the proper
But you're talking
environment.
about on the ICPM.
Yeah.
Okay, that's fair. Prior to contract, it's just
Right,
like
right.
I agree
Right.
with that
Yeah.
because if we want to take it on contract, we want to make sure it's in good standing.
Yeah.
I agree with that.
And what are you going to say to the customer when you get the service report? You're going to say, "Hey, you know what? You need to fix
Recommendation.
You need to fix X, Y, and Z
Yes.
before we can do this." So
looks dirty.
back to your point. I heard you say earlier that when you see stuff like this, when you see that level of dirt, that level of lint. I mean,
Now
all
it is bad for the unit. It is
Yeah.
bad for the unit, but I know the unit's been working.
and it
So I
doesn't
know-
necessarily mean he's saying that it's
Right.
not operational.
I'm just saying though, I have more faith and trust that there's not a burned or broken component or something has failed because it's been through the ringer like
and
this.
that's been proven out to be true in your work.
Yeah, it's been true. I mean, 90% of the ones I get like this, I'm like, oh, good cleaning, do the standard refurbishment on it, it's going to work.
Wow.
It's the ones that look brand new and pristine that we get back. That's the ones I'm skittish about. Like, really? It's already back?
Yeah.
You know what I mean? Like, okay, so that's the ones you kind of want to dive into deeper.
That might be a case by case as well.
It's a case by
I
case.
think so too.
It's a case by case, but like I said, 80% of the ones I get like this, do a deep cleaning, probably replace the fan, refurbish what I need to, put it in, burn it through, however long I got to, and then it's back out into stock inventory.
Cool.
Yeah.
All right, Elvis, hit those questions,
Let's
please.
jump on those. Master King, thank you, Lenny. Highlander, this is an awesome presentation for the viewers that aren't familiar with electrical. Agreed. Larson Epram, loving the rabbit hole, guys. GPS version of how it's made sounds like a great series idea. Love it, Larson. You've been coming with great ideas. You guys have any ideas? Email me at ven@gruber.com. Any did you knows or any ideas for the show that is in subject to UPS? Highlander, Lenny stopped giving away his secrets. Loretta, hey Claude, you look like you have blonde hair. The Scheffler family, hey Loretta. Now I like it when they're talking to each other. Yanni or Johnny Nishenen, no redundant power supply in module.
That's a question. Is there a redundant power supply inside the module?
Is there? Yeah, inside the power mod.
Yes.
There is a redundant
There
power
is a
supply.
power supply card, or there's a function built into the module that powers the module itself, and then when the module is powered on, that's powering the system. Like we showed that card earlier, the power supply card, you would consider that redundant because without that, the module's not powering on at all.
Okay.
So once that card's in and it functions properly, then the power module will actually come on, and then it'll function and power whatever's connected to the UPS.
Very nice.
This is a network card. Okay.
Yeah.
So the one that we showed where we explained all the caps and the IGBT, the heat sinks.
But there is a redundant power supply in it. Two of them.
It's not a power supply per se. It's a card usually.
Okay.
Right.
Master King says replace the board. Nolan Stanley. Hi, Dad. Is that you?
Hi, mister.
Okay, that's you. Slim Jim. Love the hats. Where's Lenny?
It slows me down. I got aerodynamics.
Master King, don't mess with Elvis. Heck yeah, I like this Master King. Highlander, I'm so proud of my Romanian cousin by another mother for his technical skills. Thank you. I think he was talking about when I went on my little tangent rant on the PCB boards, depending what it is.
When you threw the wrench in it?
Yeah.
Okay.
Romanian wrench. Pasha, that's wild. Is there additional filters or something the customer can do to avoid that? And Logan V.
Okay, well, we'll respond to that. Okay, that person is talking about the dirt that they're seeing inside. Is there any additional things
to avoid less dirt,
to avoid
dust?
This scenario.
Keep it away from any entryway, exit ways. Doors can actually bring in dirt and things, like their
Proper environment.
Yeah, basically look at your environment. Keep it away from any manufacturing areas. Keep it away from any construction areas. Keep it away from anything like that. That it's mostly like in the manufacturing industry. Keep it away from stuff that's producing particles that can get into the air, dust, dirt, whatever. Also, try not to put them in closets. Closets cause them to overheat. Closets.
I hope the customers are listening to that answer.
These things generate a lot of heat. So try not to put them in an enclosed area.
I've told them that so many times.
Yeah, we run across quite a few that are
trying
in
to keep them in a cooler area, but also, like I said, it's based on the environmental conditions. Keep it away from manufacturing environment.
And it's something we've discussed on our show many times is the location, the environment. I have a customer that says, hey, I just bought these batteries a year and a half ago. I'm like, okay, well, our FE just said they need to be replaced. Well, I just bought them a year and a half ago. I'm like, yeah, but you have them in a room, in a closet that's 80 degrees. What do you want? It has to go between, we've talked about 68 to 75 degrees. You want to keep it in the high 60s, low 70s. And they're like, well, it's a year old. I'm like, yeah, but the conditions, like, buddy, you're putting it in a spot. It's the same thing when you drive a car and it has 150,000 miles in 2 years. Well, you've been putting it a lot. It's not necessarily expected to do that in a 2 to 3 year span.
You actually said that to this customer?
Yeah.
Wow.
And you know what he did? He listened.
He listened and
After 2 or 3 field service reports and his unit's down, he had no point but to listen.
and he bought more batteries?
Heck yeah.
Wow, man, you got the magic touch, buddy.
No, I'm just honest. And I'm telling them, hey, dude, all that heat that you're generating is not good.
I
Wow.
went to, when you sent me in the field a couple of times, I went to do a service report or PM, and I actually walked into a closet, and it was 93 degrees.
Yeah.
I was like, you have got to be kidding me. I can't even stand in here to do the,
Yeah.
do the full report.
Now listen to
That's a
this.
sauna for a
Now
UPS.
listen to this.
But
Listen to this.
93
Go ahead.
Did you hear what he just
He
said?
can't even
Can
stand
you
it.
imagine this guy walking into a closet at 93 degrees? Look at this guy.
Yeah.
Come on.
So it was
Wow.
like, you got to be kidding me. And I actually talked to the customer on site, and they're like, yeah, that's a corporate thing. I'm like,
Yeah.
That's sad,
that's a and all you can do is educate. Like you said, you educate customer, you lead them to the water, and
I
then you
told
let
them
them do
too.
the rest
Can't
at
make 'em
that
drink.
point.
No,
Yeah.
make 'em
Can't
drink.
force them. I did
Well,
that with a
93
customer.
degree weather, you better start drinking.
I did that when we were in Scottsdale. They called me in and they're walking me through. I'm like, man, beautiful location, beautiful facility, all this high tech medical equipment. And they bring me to the UPS Smart Ups 10K in a closet with their like toilet paper, equipment, extra like storage. And I'm like, where is it? They're like, at the bottom. I'm like, oh, Holy Spirit. They said, well, we have a fan next to it. And I said, you can have 10 fans. I don't care. You literally put it in prison and you put it in a death trap.
Yeah, and you're burning all that electricity with these 10 fans.
And then it's like, oh, but these batteries are a year old. I said,
Yeah.
buddy, and they're probably dead. And I looked at it, and then I went and I gave them a quote. They're like, we didn't know it was this. I'm like, you put it in such a funky location, and the environment is it's the first thing you need to take into account when you have a UPS.
And I know
Your
what you said.
environment.
I know what you said after all that.
Go
after
ahead.
saying all that, you know what you said to that customer after that? You said, let's go to lunch.
Yeah.
That's
No,
what
I'm
you
gonna say
said. You said-
I told them
you said,
let's go to therapy because we need therapy after you put like what's wrong with the UPS? Do you have an hour? Like where they put it too, it's like, oh, but it's fine. It's like, dude, you're putting it in a dungeon and you're saying, oh, it's fine. It saw daylight.
Do you mind if we show this one last board real quick?
go right
I just
ahead.
want to.
Go ahead and grab it. So Logan V says, nice hair, Elvis. Thank you. It grew overnight.
So
Loretta Bauman.
If you guys are wondering our technical skills here at Gruber, we actually do have a board here that possibly is not repairable.
You're going to have to hold it up, Lenny.
So
That's not
Yeah.
repairable.
this is actually not repairable. This
Wow.
was in a 4KP, right? And the room flooded. This
Okay,
was
took a
actually
nap.
still turned on when the room flooded.
You could see the rust.
So the
in
module
rooms.
was halfway full of water. And this board sits on the bottom part of the module inside. And of course, it blew it up, rusted it.
Wow.
There's actually scalable hard deposits from the water from where it was sitting and stuff like that. Now, something like this, we can't refix. Just to be honest, but something like that, that's not a problem. But yeah, I mean, it takes a lot for us not to be able to really repair a lot of things. But this is like the most extreme I've ever seen.
Yeah. I mean, even if you could repair it, you wouldn't want to.
I wouldn't want to because
the
you don't know.
fiberglass is all destroyed and all that.
You don't know what's inside of a relay
Yeah.
or anything that's not water
Claude,
sealed.
what have you said with equipment like this? What's something you don't even need to be technical? What are some of the things you have to use? Your what?
Your senses.
Did you smell that?
I did.
I smelled it. That smelled interesting.
Yeah.
It
Before you even
smelled
open-
wrong.
Before you even open it up. You
Yeah,
can-
you can smell it. Okay, so
I
then
smelt it from over here.
right? It's crazy. So a lesson learned: don't baptize your power modules in water because they're not going to come back brand new.
That's right. They're not going
Sorry.
to come back. There's
Yeah.
no new life.
No new life. It's
Yeah.
dead.
All right, so we're at 11. So I got to change the gears real quick. Okay, Elvis, I'm like gonna totally change gears here.
You're going to acknowledge me?
Yeah. Well, listen to this guy. did I miss acknowledging you in the beginning? No, seriously, did I?
No, we're twins.
Okay, because I did that. I've already done that once, and you spanked me over this.
I'm not going to let you forget it.
Yeah. Okay, so the next show is the last one for 2023. And we want to have some fun at the end of it, like the last 15 minutes. So what we're going to ask some of our audience people, well, actually all of you, if you want to do this, first of all, I need for you to take my phone number. I don't know if I should do that. But
Oh, you should
Here's
do it.
my business number. Go
So
ahead and
this
take
is a
it.
cool one.
So write this
Email.
down, or watch the podcast later. My number is 480.
Oh my gosh, you're giving your do your email.
No, because I want the 244.
Oh wow.
3028. Okay, that's my phone number. And what we're looking for is your best laugh. Okay, it has to be genuine. So you got to watch something that's funny, that makes you giggle, makes you laugh.
Nothing creepy.
And you record yourself in a voicemail and you send it to me. And what we're going to do is we're going to collect these laughs. We're going to put them all on a, what do you call it, a string?
Yeah,
Is that
an
what you call
audio.
it?
Yeah.
On an audio.
And then
yeah.
this is my favorite part of
And
this
then we're
idea.
going to play each one and have you guess whose laugh it is.
Whose laugh it is. So
And we
it's
have-
like
and
guess
we have-
the laugh.
Like this one. I have one I'm going to do right now. I want to see how many people that are watching
Let's
that
see
are
if
from
they can
Gruber
guess it.
that can guess who this is.
I already know who that is, and they're probably not watching.
And I'll give you a hint. This person comes downstairs intermittently,
Yep.
okay? And most of the time he's talking to somebody. Oh, I gave it away. See, most of the time he's talking to someone in service, and his laugh it's the baritone.
You can hear it all day.
It vibrates the whole room. So that's one laugh right there that I hope we get.
You can text me at 867530999.
Okay. All
Just
right.
text Claude. I can't believe you gave your number out.
Hey, Claude, what's that number again?
Here's my business number, 480-244-3028.
And let's hit up the last of our people today with bye. Have a Merry Christmas from Loretta.
You too.
Merry Christmas, Loretta. Pasha. Merry Christmas, guys. Have a great weekend. Thanks for the info. Merry Christmas, Pasha. Master King. Dust, humidity, high temperatures are unfavorable conditions for a UPS unit. You hit it on the head. With all that, we went into the deep, but that's a great, conclusion to that. Larson Epram. Is it normal to have an air-conditioned room dedicated to their UPS? Yeah, it should be. I mean, data centers do that. So data centers have an air-conditioned room with the raised floor and all that, and they keep it within the 60s and low 70s. With that is the industry standard, I would say, for a UPS Larson to answer that. That's a requirement.
That should be part of the topography.
All day. You've said that before, the topography, when you come in and you do all the schematics and you do the planning, that's from day one. How hot's it going to be in there?
That's right.
All
So,
day.
do you guys have any did you knows today, or did you?
Yeah,
just,
we can hit some.
Or did you space it?
No.
Okay.
No, we have a lot, but we'll give those for next week. But what I will do is, in respect and thanks for what Lenny has done and showing up, I'm gonna give just the three. Did you know that Lenny shared with me?
Okay.
So the first one is Tom Hanks played how many different roles in the movie Polar Express? That's a classic Christmas
Yeah, I
one.
love that movie.
How many roles did he play? We're gonna have them answer. It's really cool. And he actually played one that I didn't know, but this week I watched behind the scenes, and I didn't know that he'd actually played one of them too. I will give away the one. Actually, I'm not going to give it away. It's the hard one that a lot of people wouldn't expect.
The conductor.
Yeah, right? Yeah, exactly. The hardest one is the one I didn't realize. Do you know which one was the one of them? How about Aaron or Lenny? What's one of them that is not common from the six that he played, but he did play them?
I've actually never seen the Polar Express.
Oh, wow.
Yeah, that's a great movie.
Great movie.
Yeah.
Richard, what do you know?
Ditto with Aaron.
What's wrong with you guys? You guys don't have kids.
We're more of a bad Santa crowd.
I
back
figured.
here.
Yep.
Hey, that's
for
a part
another
in
one.
Phoenix, at least.
Yeah. Okay, no one put anything. Lenny, Claude, how many roles were there?
I'd say 5.
5. Close. You know it.
How many roles?
Yeah, did he play
6.
6? And he played, one of them was the kid,
Yep.
the child. Go figure. They took his face and they made him younger, and he even played the voice a little bit. Now, the history of Santa Claus dates all the way back to the 3rd century to a Turkish monk named Saint Nicholas. Jingle Bells was the first song played in space.
That's two different ones, right?
I did not know that part. So Jingle Bells is the first song ever played in space. That's fascinating.
It is.
And then the last one, I mean, I love this.
This is the one that shocked me the most. Not the first part of the Did You Know, but the second half of this Did You Know.
Okay.
It's really shocked me.
Bing Crosby's classic song "White Christmas," which is "I'm
Dreaming of a white Christmas.
Doo-doo, doo-doo, doo-doo. Is not only the best-selling Christmas song, but the best-selling single of all time.
Wow.
Right?
Of all time holiday or
all
just
time.
all time?
Do, 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 do. By him. By him.
And it's that version,
it
right?
may not be Bing Crosby. It may be Bing Crosby, but they
That
list
song.
Just
that
the
White
song.
Christmas is the single of all time, and it might be Bing Crosby version.
Is it
too.
that version from the Home Alone?
I'm not. Where he's playing with the cutouts. Yeah.
Okay.
Yeah.
Yeah, that's amazing. That is absolutely amazing.
I love in that scene, he has Michael Jordan.
He has
Because
Michael
I'm a Jordan
Jordan.
guy, so he had Michael Jordan as one of the cutouts.
And
so
then
it made-
recently they redid that scene, and he had LeBron James
That's
as
awesome.
the Michael Jordan.
That's really cool.
So yeah.
So, I mean, we got to just a few little Did You Knows, but we will survive because next week we have one more show.
Yes.
For the end of the year. We're going to do that audio guessing game, the really cool audio guessing game, and send it to Claude's text. This time, send it to him. Don't even think about me. Do not email me nothing. I'm good. And this was awesome, man. This
Yeah.
was fun. Look at that.
Yes.
We're coming to the end of the year. I mean, we finished, Claude.
So how can you find us? You're good. See, you're good with this stuff. How can you find us?
Here's the best way to get in touch with us. Jump on YouTube at Gruber Power Services. We're also on TikTok with Gruber Power Services and Instagram. I want to give a shout out and I want to thank Instagram that from what Aaron's told me, we are growing at such a rapid pace at Instagram. I think we're over 20,000 followers. And I kid you not, a month ago, we were at about 7,000 or 8,000. And we've jumped to over 1,000 a day, I think, at one point. Aaron, if you want to touch on that.
Yes, as of right now, 20,183 followers on Instagram.
Yes. And we are growing at a rapid rate on these platforms. So if you want to go and just subscribe to YouTube, like, subscribe, and share, please comment. We love and we can't stress how appreciative we are of everyone that chimes in, from Highlander, from Loretta, from her friends and family, from all the connections,
Luxor.
chemistry, from Luxor, from Romania,
Yeah.
from Egypt,
Yeah.
from India we have, from Serbia we've had, from all across the world. Just keep jumping in. We appreciate it. So on YouTube, like, subscribe, and share, and then comment. And then on TikTok and on Instagram, we have the same channels. And then we have all of our channels that are parallel and go across. The Gruber Motors,
Yeah.
the Gruber, the comms, the AI in
Yeah.
YouTube. We have so many. Pete's doing this great new series on rants. So there's so much content we're doing here to really challenge and to educate people. Because you said this from day one, and I'll never forget it. We are not the be-all, end-all, and we are not the experts in everything. And we don't say we know it all, but we are professionals. We are growing and learning, and we are in this field with some really good experience. And someone like Lenny that's been at this for so many years. How long have you been at this?
Here at Gruber for 2.5, but
No,
I mean,
but in this industry.
in the industry, power IT industry for the past 36 years.
36
Yeah.
years, starting back in military.
Yeah.
You've been at it, what, 14, 15?
Yeah,
And
yeah.
I'm at 7. So
Yeah.
there's so many people here that can help us, and we're growing and learning. So
Hey,
fun stuff.
Well, to close it out, I would be remiss if I wouldn't give credit where credit is due. And that thing that we're going to do next Friday, that ideal actually came from my wife, 𝐓𝐢𝐦𝐞 Dixon. That
Very
was
cool.
her ideal. It wasn't mine. And we heard it, and I ran it past Elvis. I said, we both said, it's like, that's a great idea.
We love it.
So we're going to see how it goes. But what's most important this time of year is what you're getting ready to do this weekend. And that's spend time with your family. And then
Exactly.
on Monday, spending a Christmas with your family. So all of us want to wish you and your family a Merry Christmas.
Merry Christmas.
Christmas.
I think I lost like 5 pounds.